Welcome back, engineering students, diploma candidates, PLC programmers, and automation pros. I am absolutely thrilled to have you here for this explainer. Today, we are unpacking something huge, a technological revolution that is literally rewriting the rules of industrial production. We're talking about Industry 4.0. If you've ever found yourself wondering exactly how artificial intelligence, cloud computing, and massive heavy machinery all blend together to create the autonomous plants of the future, well, you are in exactly the right place. We're going to completely decode the complex systems driving today's smart factories and digital manufacturing. So, here's our quick roadmap for today's explainer. 1. The shift to 4.0. 2. The smart factory core. 3. The automation workflow. 4. Applications and benefits. 5. Challenges and future trends. And finally, 6. Realizing the future. All right, part 1, the shift to 4.0. To truly appreciate the sheer power of connected industries, we really need to understand the journey that actually brought us here. Let's look at how this evolution builds across history. It's like a giant puzzle coming together. Industry 1.0 kicked things off with mechanization through water and steam power. Then came 2.0, giving us mass production powered by electricity, a massive leap. Not too long ago, Industry 3.0 completely changed the game with early computers and basic automation. But today, we are firmly in the era of Industry 4.0. And this isn't just about computers doing basic math anymore. It's all about cyber-physical systems. The digital and physical worlds are completely, seamlessly intertwined. So what does this actually look like in practice? Well, think of Industry 4.0 as a kind of master equation. It's the combination of smart factories, digital manufacturing, complete automation, and connected industries. We aren't just swapping out human muscle for machine muscle anymore. We're replacing isolated, standalone machines with highly communicative, intelligent networks that can, quite literally, think for themselves. Moving right along to Section 2, the Smart Factory Core. We are about to unpack the heavy hitters here. The absolute backbone of the modern plant is the Industrial Internet of Things, or IIoT. Think of this as the central nervous system of the factory. It's this massive network of sensors, instruments, and autonomous devices, all connected through the internet to industrial applications. It is constantly pulsing with real-time data, and it's communicating all of this without needing a human to act as the middleman. It's totally autonomous. Now, if IIoT is the nervous system, then programmable logic controllers, or PLCs, are the fast-acting reflexes. And working right alongside them, we have SCADA systems for high-level supervision, kind of keeping a bird's-eye view on everything, and variable frequency drives, or VFDs, which control motor speeds with just incredible precision. These are your core industrial computers that take digital commands and instantly translate them into heavy-duty physical action. But hey, the smart factory doesn't stop there. It needs a massive brain to process all that data, right? That's where artificial intelligence, machine learning, and big data analytics step in, supported by both cloud and edge computing to handle those immense calculations. We've also got physical robotics, augmented reality for human workers, and absolutely mind-blowing concepts like the digital twin. Just imagine having a perfect, living virtual replica of your physical factory that updates in real time. Incredible, right? And tying the whole shebang securely together is advanced cybersecurity, keeping these networks locked down and safe. Which brings us to Section 3, the automation workflow. Let's see how all these parts actually move together. Let's trace this sequential journey, because it's fascinating. It always starts with physical sensors, detecting something. Let's say it's a sudden temperature spike. That signal travels instantly to the PLC, our local reflex. The PLC then fires this data up to the HMI and SCADA systems so operators can see it, while simultaneously pushing it to cloud storage. Up in the cloud, AI analysis crunches historical and real-time data to make a highly optimized decision. Finally, that decision travels right back down to trigger precise machine control, from the physical world to the digital brain and back to physical action, literally in fractions of a second. Okay, Section 4, Applications and Benefits. It's time to ground these abstract concepts in reality and look at the actual industrial impact. The versatility of Industry 4.0 is absolutely staggering. I mean, it isn't just for making cars, though the automotive industry definitely relies heavily on it. We're seeing massive, widespread implementations in food processing and pharmaceuticals, where, let's be honest, precision is literally a matter of life and death. It's completely revolutionizing heavy sectors like cement and steel, optimizing water treatment facilities, and it's even branching outdoors. We're seeing it in smart agriculture, solar power plants, and total warehouse automation.
And these aren't just flashy tech upgrades, they directly translate to massive, real-world benefits. Look at the correlations here. A robot assembly line means higher production volumes and lower long-term costs. AI quality inspection basically removes human error entirely, giving you zero defects and superior quality. Even with smart irrigation in agriculture, the automation directly leads to huge energy and water savings.
Actually, scratch that. If there is one true financial game changer, it is definitely this slide right here. Traditional manufacturing relies on reactive maintenance. You know the drill. You fix a machine when it breaks, which leads to massive, expensive downtime. But Industry 4.0 introduces predictive maintenance. Because the AI is constantly analyzing machine vibrations and temperatures via those IIoT sensors, it can tell you exactly when a part is going to fail before it happens. You replace it during scheduled downtime, saving companies an absolute fortune. Moving on to Section 5, Challenges and Future Trends. Upgrading an entire industry isn't exactly a walk in the park. Implementing these systems means we have to acknowledge some major roadblocks. First up is the high initial investment. Outfitting an old, legacy plant with sensors and robotics, yeah, it's costly. Second, expanding your digital footprint drastically increases cybersecurity risks and data privacy concerns. Plus, integrating brand new AI with older legacy machinery is a massive headache for IT teams. And crucially for us, there is a massive shortage of skilled engineers who actually understand both the software side and the heavy machinery side, which honestly is exactly why mastering these concepts gives you such an incredible edge in your career.
But the march of progress absolutely does not stop. While we are busy mastering 4.0, the horizon is already showing signs of Industry 5.0. This next phase focuses heavily on human-machine collaboration. We're talking about cobots, collaborative robots that work safely right alongside humans on the floor. We are also rapidly moving toward fully autonomous AI factories and eventually integrating these smart production hubs directly into the infrastructure of future smart cities.
Finally, Section 6, Realizing the Future. Theory is fantastic, but who actually builds the bridge from legacy systems to smart factories? Well, DEVI Automation Solutions is a prime example of the kind of experts bringing these exact concepts to life every single day. Their whole mission is focused on combining smart technology to deliver powerful solutions for a better tomorrow.
And they are doing this across the board. DEVI provides comprehensive services ranging from foundational industrial automation and complex PLC, HMI, SCADA, and VFD programming, all the way up to advanced AI and IIoT integrations. They even scale this tech into smart agriculture, home automation, and solar solutions. If you're looking to dive deeper into any of these specific topics, definitely subscribe to the DEVI Automation Solutions YouTube channel for more technical breakdowns, or you can just reach out to them directly at deviautomationsolutions@gmail.com for any business inquiries.
Which brings us to our final thought for today. We've just seen how machines are getting smarter, faster, and more connected than ever before. The traditional factory floor as we know it is disappearing, being replaced by digital twins and highly intelligent networks. This technology is advancing relentlessly, and it's not slowing down. So the real question I have for you is, as these smart factories become the new global standard, what steps will you take today to upgrade your own skills and become an architect of this automated future? Keep learning, stay curious, and I'll catch you in the next explainer.